Hello everyone, I am Mithun Chakravarti. In this Practicum 13 of our computer organization and architecture, we are going to see the GPU execution on NVIDIA Jetson Nano. So, the experiment using this NVIDIA Jetson Nano board demonstrates the key concept of parallel computing by comparing CPU sequential execution with GPU's parallel execution processing. So, through vector addition, students are going to understand the data parallelism where the same operations is applied simultaneously to the large data sets, highlighting the efficiency of GPU architecture with multiple cores. So it also introduces the memory management concepts such as data transfer between CPU and GPU using QPy, which is a module in Python. So and enables the performance analysis by comparing execution time with NumPy. And overall, the experiment strengthens the understanding of GPU computing and memory hierarchy and real-time embedded processing application. So when we enter into our practicum, so first we are gonna boot our Jetson Nano board by inserting a SD card with Jetpack SDK and power on the complete initial setup. And we are supposed to install a particular libraries like sudo apt update pip3 install numpy and pip3 install qpy qda where this pip install is used for installing and this numpy qpy qda all these are just an modules and this is the experiment procedure. So when we come to the programming part, so we are importing numpy, qpy and time which is used for CPU computations, GPU computation and measuring the execution time. And we are defining the size of array which is smaller size suitable for Jetson Nano where size is equal to 10 power 6. And CPU section, we are generating a random array on a CPU where this is the CPU section. Just we are just generating a random array and where a CPU equal to NP of random of rand of size and B is also the same. And we are starting the timer from the CPU execution and we are performing the execution addition and we are calculating the CPU execution time. So when we come to the GPU section where as same transfer data of CPU numpy to GPU, the same array is being given here and we are starting the timer and performing the addition to the GPU. And we are also ensuring that the GPU finishes computation before the stopping timer. And we are calculating GPU execution time and we are finally printing it. So this is the sample input and sample output where we can see clearly here that the CPU's execution time is 0.0045 and the GPU's execution time is 0.0030, which is 15 seconds. I mean, the micro 15 seconds is below where the GPU is good in the parallel processing execution, where GPU is sequentially executed. So we can clearly understand that the execution time and the number of cores inside the GPU is very efficient to do the processing parallelly, where GPU have a minimal of cores. So, I mean, the CPU has the minimal of cores, so the process is being executed sequentially. So, thank you.